to your Chapter 3, Lesson 1 video. So in our first lesson for Chapter 3, the first thing we're going to be doing is we're going to be graphing linear equations. So our ability to graph is something we're going to be able to do. One of the things we're going to do is we're going to identify linear equations. So we're going to be able to look at an equation and tell you whether or not it's going to make a straight line. That's what linear means. We're also going to be able to tell you intercepts, where it hits the x or y axis. So when we're graphing these, we're going to be able to say this is where it hits the y-axis, this is where it hits the x-axis, these are the intercepts. If we can tell the intercepts, then we can tell the zeros. Zeros are where you plug in 0 for x or you plug in 0 for y and you solve your equation. After we do that, the next thing we're going to do is actually graph some linear equations by using intercepts. So the standards that we're going to be addressing is functions and interpreting functions, standard number 4, functions, interpreting functions, standard 7a. Let's go ahead and start our lesson. Before we begin today's lesson, there are 4 vocab words I want you to copy down. The first one is a linear equation. A linear equation is a graph that makes a straight line. So it's an equation of something that makes a straight line. Now in a linear equation, x is always to the first power. The next thing is what we're really going to focus on heavily in today's lesson. So that's why it's got stars. Standard form. Standard form is a linear equation. It's actually this equation here. ax plus by equals c. So make sure you copy down this equation, maybe put a circle around it, maybe put a box, highlight it, whatever you got to do. But standard form is always the equation, ax plus by equals c. It's a linear equation. So what that means is if you were to actually graph this equation, it's going to make a straight line every single time. Now, a, b, and c all have to be integers with a greatest common factor of 1. A always has to be positive because it always has to be greater than or equal to 0. So any number that's greater than 0 is a positive number. So it has to be greater than or equal to 0. And since it's an integer, it really shouldn't be a decimal. Like it shouldn't have a decimal expansion or it shouldn't be a fraction. Now, an x-intercept is where the graph hits the x-axis. Now, when you're at the x-intercept, the y is always going to equal 0. So if you want to find the x-intercept in any equation, all you got to do is put 0 in for y and solve for x. If you want to find the y-intercept, that's where the graph hits the y-axis. What you got to do? Plug 0 in for x and solve for y. So if you're finding the x-intercept, plug 0 in for x. Alright, if you're finding the x-intercept, plug 0 in for y. If you're finding the y-intercept, plug 0 in for x. And those would be how you actually find them. You put 2 dots right there, connect that, and that's your line. And that's how you can graph some linear equations. And we'll see that in today's lesson. Let's go ahead and start. In our first example, we're going to look at this equation. We're going to determine whether or not this is a linear equation. So we just need to be able to say, is it a linear equation? Now, if it is, we have to write it in standard form. So most of the time, we're going to try to get the equation in standard form if we believe it is a linear equation. Now, there's 2 rules that you kind of want to look for when determining if something is a linear equation. The first rule is x and y have to be to the first power. So we look at x and we look at y, and they all are to the first power. Because they don't have an exponent, that means they're to the power of 1. So right now, this passes rule 1. But in order to be linear, it doesn't just pass rule 1, it also has to pass rule 2. You cannot divide by x or y. So looking up here, we're not dividing by x or y. And there's one more rule that I forgot to add. You cannot have multiplication of x and y. So we cannot have x and y multiplied by each other either. So technically there's 3 rules that you have to be able to say, okay, this doesn't happen, okay, we're good to go. So looking at this, we don't have x and y multiplying here, but we do have x and y multiplying there. Since x and y are multiplying, this is not linear. So what I would say is, since x times y is multiplication, or multiplying, this is not linear. So the answer to this problem is this is not a linear equation because we have x and y multiplying. And that's one of the rules that it cannot happen. We cannot have multiplication of x and y. So this is not linear. Let's go ahead and do another example. For example 2, we're going to be solving 3/4 x plus y equals 8. We look at the rules. X and y have to be to the first power. X and y are to the first power. You cannot have division of x or y. Well, we don't have any division of x or y. And we cannot have multiplication of x and y. And we don't have x next to y multiplying. So right now I can tell you this is going to be linear because it passes all these rules. But since it's going to be linear, we have to put it in standard form. We have to have a whole number with x, a whole number with y, and a number by itself. But if we look at our problem here, we have 3/4 x plus y equals 8. And we have to make it look like a number with x, a number with y, equals a number by itself. So the way standard form says is we have a number with x, a number with y, equals a number by itself. Well, this is not a number, this is a fraction. So we need to get rid of the fraction part. We actually need to get rid of only division. So when you have a fraction, only get rid of division. To get rid of division, we do the opposite of division. We do multiplication. So we multiply not just one number by 4, but every single number is going to multiply by 4. To get this to actually work right, we have to multiply all numbers by 4 to make it right. Well, a 4 divided by 4 cancels out. Now we have 3 with x plus 4 with y, because 4 times y is 4y, equals 8 times 4, that's 32. And now it's in standard form. So yes, this is linear because we're able to get it in standard form. Also, it passes all 3 rules. X and y are to the first power, x and y aren't being divided, and x times y isn't happening. Since that's the case, we can make it standard form, so that's what we had to do. And in this case, whenever having a fraction, all we want to do is get rid of division. To get rid of division, do multiplication. When you multiply one number, you have to multiply all numbers. Let's go to example number 3. Alright, in example number 3, we're going to be solving the equation y equals 4 times x minus 5. And what we're going to do is we're going to determine if it's linear. So does it pass all 3 rules? If it does pass all 3 rules, it's linear. So x and y have to be at first power. X and y don't have an exponent. They're to the first power. We're good. You cannot have division of x or y. Well, we don't have division of x or y, so we're good on that as well. And we cannot have multiplication of x and y. We don't have that either. We're good to go. So if our equation was y equals 4x minus 5, and I need it to look like a number with x and a number with y equals a number by itself, one of the things you want to notice is that we always want to have x and y on the same side. So in this case, we want to put x and y on the same side. But we have one rule. We need to always make sure that the number or the a, or the number that's with x, is always a positive. So looking at this, this is a positive number. So we can move that over here, but then we're going to have to get rid of that. If we moved it over here, we're going to make it a negative. Since we want it to be a positive, we're going to flip 2 things around. One of the first things we're going to flip around is this y. So to get rid of 1y, we're going to subtract 1y. And if we subtract 1y from one side, we're going to subtract 1y from the other side. 1y minus 1y is going to cancel out. And if I had a y and I took away a y, I have nothing left. We have 4x's minus 5 minus 1y. Now, it's almost in standard form just by moving that y to the other side. The only thing is, you're only allowed to have x and y on the same side in standard form. So in that case, we want to get rid of this minus 5. To get rid of a minus 5, we add 5. If we add 5 to one side, we add 5 to the other. 0 plus 5, that's 5. we have 5 equals 4x minus 1y. And that's our answer in standard form, which means this, in fact, is a linear equation. Again, the number that's with x always has to be positive. We have a positive number with x. They're all integers. And it doesn't matter what number's with y. What matters is that the number with x is positive. So we have x and y on the same side. They're all integers. And we have a number by itself. That's standard form. We knew it was linear because it passed all 3 rules. So let's keep moving, and then let's actually go into graphing linear equations in standard form. Before we actually get on to graphing x and y, before we actually get on to graphing in standard form, one of the things that we need to be able to do is to be able to identify intercepts. So our vocab word was x-intercept, y-intercept. Now, notice that whenever you see a graph, we have a line that goes vertical, and that's our y-axis. We have a line that goes horizontal, and that's our x-axis. Now, an intercept is any time your graph hits the line or the axis. If it hits the x-axis, that's an x-intercept. If it hits the y-axis, that's a y-intercept. So one of the first things we need to be able to do in math is be able to determine x and y-intercepts. We're going to be using those all throughout this year. So it's very important that you know what an x-intercept is and a y-intercept is. And if you don't, just make sure you can look at your graph and say, where did it hit the line that goes up and down or horizontal? So when looking at this, you want to say, okay, well, here's the y line. It hits the y line at 200. So you would say that there is a y-intercept at 200. That's the first thing. We have a y-intercept. It's at 200. Then we would also say that there is an x-intercept, and we look for where this graph hits the x line. It's hitting the x line at 4, so we say there's an x-intercept at 4. So for this problem, we do have a y-intercept, we do have an x-intercept. Those are at 200 on the y and 4 on the x. In example 5, we're going to be solving x and y-intercepts from a table. So one of the skills that we should have other than looking at a graph and saying this is where it hits the y line, this is where it hits the x line, is to be able to determine intercepts by zeros. Now, if you remember when we copied down the vocab, we said that the x-intercept is when y equals 0, and the y-intercept is when x equals 0. So we could actually figure out that information just by looking at the table. So here it says the x is 0, y is 2000. Well, if the x is 0 and we get a y answer, that means it's the y-intercept. So we could say that our y-intercept is at 2000. We could also say that our x-intercept, now to find the x-intercept is where y is at 0. So we look at the y is at 0 right here, so the x-intercept would be at 500. Okay, now, not only do we want to find the x and y intercepts, but we kind of want to determine their meaning. So, this is 500 seconds, and this is a weight of 0 ounces. So at 500 seconds, we got 0 ounces. Now I'm going to kind of fix this up a little bit better. The y-intercept is when we had 0 seconds, we got 2,000 ounces of peanuts. Okay, so if we're determining the meaning, at 0 seconds we have 2,000 ounces. At 500 seconds we have 0 ounces. So what's happening is the amount of ounces are going down. This is what our starting amount, this is our ending amount. So in order to get rid of 2,000 ounces, it takes us 500 seconds. That's what these intercepts tell us. So the intercepts are where x equals 0 for the y, where y equals 0 for the x, and if we want to determine their meaning, the y-intercept in this case is where we started, the x-intercept is where we finished. So that's our answer for this problem. For the next two examples we're going to be doing is we're actually going to graph by using intercepts. So we looked at how to see an intercept on a graph. We looked at how to see an intercept on a table. On a graph, all you have to do is say where it hits the y line and where it hits the x line. Now, in a table, that's where you look for y being 0 and x being 0, and those are your intercepts. We're going to use that idea that y is equal to 0, that's the x-intercept, x is equal to 0, that's the y-intercept, to now actually graph some equations. So we're going to graph two equations. And we're going to use this equation here to start with our graph. So what we're going to do is we're going to kind of solve two equations. So we're going to plug in 0 for x and solve, and we're going to plug in 0 for y and solve. And after we plug in 0 for x and 0 for y, we're just going to go ahead and make a quick graph right here of what that graph looks like. Now, I don't expect perfection, but I do expect you to be actually able to put 2 points on the graph and connect those with a solid line. So graphing something that we know is going to be linear is actually going to be hopefully fairly simple for you. What we're going to do is we're going to start with saying that the first one we're going to solve is, we're going to say x is equal to 0. And so we write this equation. We have 4 times x minus y equals 4. Now, if you notice, I automatically put my x inside parentheses. And that's because I know I'm going to make that x a 0. Because the x, or the y-intercept, is when x is equal to 0. So, now, before you actually begin, anytime you have a variable by itself, you always want to put a number 1 next to it. So this is really 4x minus 1y equals 4. And that's what we're actually going to go ahead and graph. Well, we're going to put in 0 for the x. So here's x. We're going to put 0 in. When we put 0 in for x, we're actually figuring out the y-intercept. So we have 4 times 0. We're going to take away 1y, and that's going to equal 4. 4 times 0, that's 0. 0 minus 1y equals 4. 0 minus 1y. 0 minus anything is that same number. So it's a negative 1y equals 4. Now, all we have to do is solve for y. We divide by negative 1, divide by negative 1. This cancels out. We get y equals 4 divided by 1. That's negative 4. So this right here is our y-intercept. So we just figured out our y-intercept by plugging in 0 for the x. So we have 0 for the x, negative 4 for the y. Now, the next thing we're going to do is we're going to plug in 0 for the y and solve. So this one is going to be where y equals 0. We're going to rewrite this equation right up here. We have 4x minus y, and I'm going to put y inside parentheses, equals 4. The reason why I'm putting y inside parentheses is I'm going to make my y, which is right here, 0. We have 4x minus 0 equals 4. Notice that I changed the letter y to 0. Well, if I take 4 x's and I minus nothing, I still have 4 x's. Now, I'm going to solve for x. We divide by 4, and we get x equals 1. So that's the hard part. We just figured out the x-intercept, and we figured out the y-intercept. Reminder, the x-intercept is when y equals 0. So we plugged in 0 for y, we get the x-intercept. This is the x-intercept number. Then we plugged in 0 for the x, and we got the y-intercept. This right here is the y-intercept number. Now, once you have your intercepts, pretty simple to graph. All you got to do now is you go ahead and make a coordinate grid. To make a coordinate grid, you draw a line straight down. You draw a line straight across. Go ahead and label the line that goes left and right, x. Label the line that goes up and down, y. Go ahead and put about 5 marks on it. Try to keep your marks equal distance apart. Now, you don't have to worry about these numbers, but these numbers are kind of important. They're just numbers that you need. We know that it's going to hit these lines. It's going to hit the y line, because it's the y-intercept, at -4. So here's the y line. Here's 0. We go -1, -2, -3, -4. We put a solid dot right there where y is -4. Now, this is the x-intercept. And x is going to equal 1. So you go to the line that's labeled x, which is the one that goes this way, and you go where 1 would be. If this is 0, you go over 1. That's where 1 is. You put a dot there. Now, if we have to graph this, all we have to do is connect dot 1 and dot 2 and make it with a solid line. We just graphed our very first linear equation in this class. All you got to do is plug in 0 for y, solve for x, plug in 0 for x, solve for y, and put those points on a coordinate grid and connect those dots, and you got your solid line. So whenever you have a number in standard form, it's easiest to plug in 0 for the x, solve for y. Plug in 0 for y, solve for x. Let's do one more problem that we have to graph by doing this method again, and then we're done for today. For our final example, we're going to be graphing 2x plus 5y equals 10 using the intercept method. The intercept method is where you plug in 0 for x, you solve for y, plug in 0 for y, solve for x. All you got to do is put a dot where your y-intercept is on the y line. Put a dot where your x-intercept is on the x line. And then connect your two dots with a solid line, and that's graphing the linear equation. As long as we know that this equation passes all three rules that we started with, we know it's going to make a straight line. So, we have x and y to the first power. They're not multiplying, they're not dividing. This is a linear equation. Also, this is actually in standard form. We have a number with x, we have a number with y, and we have a number by itself. So in this case, 2 is a, 5 is b, and 10 is c. And again, notice that the number that's with x is positive. So what we're going to do is we're going to graph using intercepts. The first one, I'm going to go ahead and say, in this case, I'm going to use y is equal to 0. So I'm going to write this equation, 2x plus 5y equals 10. Now, if I'm putting y as 0, then I'm getting the x-intercept. So I'm going to solve 2x plus 5 times 0 equals 10. 2 times x plus 5 times 0, that's 0, equals 10. If I have 2x plus 0, I get 2 x's. If I want to solve for x, all I got to do, divide by 2, and we get x equals 5. So x equals 5, this number of 5 is my x-intercept. So all I have to do is look at my horizontal line and put a dot right where 5 would be, and that's the x-intercept. The last thing I got to do is solve when x is equal to 0. So what we do is we rewrite this equation one more time. 2x plus 5y equals 10. And in this case, this is where we're going to change the x to 0. Two times 0, that's 0. So we have 0 plus 5y equals 10. 0 plus 5y, that's 5y. And to solve for y, we're going to go ahead and divide by 5, and we get y equals 2. And the y equals 2, this is our y-intercept. And I know that this is my y-intercept because x is equal to 0. So last thing we got to do is what we did on the last one. We're going to go ahead and draw a line going up and down. Draw a line going left and right. I'm going to put about 5 marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the x-axis. This is the y-axis. And I'm going to go ahead and graph these using a black marker. So, we know that the x-intercept is at 5. So here's my x line. We start at 0, and we go over to where 1, 2, 3, 4, 5 would be. So we go ahead and put a solid dot on 5. The y-intercept, that's where it hits the y line. The y-intercept is at 2. So on the y line, start at 0, go 1, 2, put a dot. This graph, would look just like this. All we got to do after that, connect the two dots with a solid line, and that's it. So in today's lesson, we learned how to determine if something makes a straight line, if it's linear, just by following 3 rules. Then we looked at how to find intercepts by looking at them on a table and looking at them on a graph. And the last thing we did was we actually learned how to graph by using the intercepts by plugging in 0 for y and 0 for x and solving those problems. So that's it for today's lesson. Make sure you like this video. Hopefully you understand it. And if you don't, that's okay. We're going to be practicing in the classroom. So I will see you tomorrow. Have a good night.